we're going to dive into a piece of software called COMPAS. Now, this isn't just any old code. It's an algorithm that spits out a risk score, a single number that can help a judge decide who gets to walk free and who has to stay behind bars. And make no mistake, the stakes here are about as high as they get. This is not some academic exercise. When that program stamps high risk on someone's file, it can mean higher bail, getting denied parole, or even tacking extra years onto a prison sentence. It is literally an automated judgment with massive, life-altering consequences for real people. And that question right there, that is the absolute core of this entire debate. See, these tools are supposed to be the solution. They were built to take human bias out of the equation, to make sentencing more objective. So how on earth did one of the most popular algorithms out there end up in the middle of a massive controversy, accused of being racially biased? Okay, let's get into it. Our story really kicks off back in 2016. The nonprofit newsroom ProPublica dropped a bombshell investigation that went right up against North Point, the company that actually built the COMPAS algorithm. And it was a total showdown. You had the investigative journalists on one side and the tech company on the other. Now here's where things get really, really interesting. ProPublica's claim was pretty straightforward. They said the algorithm messes up, and it messes up in different ways for black and white defendants. But North Point came back swinging, saying, no, our algorithm is fair because a high-risk score means the exact same thing for everybody, no matter their race. And the craziest part? In a weird, mathematical way, they were both telling the truth. So let's look at what ProPublica actually found. This table shows us the two kinds of mistakes the algorithm can make. A false positive is when the code says someone is high risk, but they actually don't commit another crime. And a false negative is the flip side. The code says they're low risk, but they do reoffend. And just look at those numbers. They are not subtle. Let's really zero in on these false positives for a second. What this shows is that black defendants who were never going to reoffend were still almost twice as likely to be incorrectly labeled high risk compared to white defendants in the same situation. We're talking a 45% error rate versus 23%. Just think about that. You could be denied your freedom based on a mistake the system is twice as likely to make just because of your race. And this graph shows the other side of that same coin perfectly. When it comes to false negatives, these are the people the algorithm wrongly says are safe. The whole thing flips on its head. White defendants who did go on to commit another crime were much more likely to be wrongly labeled low risk. So, in effect, the algorithm was putting the burden of its mistakes on one group while giving the other group the benefit of the doubt. So you see that data and you think, case closed, right? But if the numbers are so clear, how could North Point even begin to argue that their algorithm was fair? Well, this is where we run smack into a mathematical wall. It's a tricky concept called the fairness deadlock, and it's the key to understanding how two sides could look at the exact same system and see completely opposite things. So, North Point's whole argument was based on an idea called predictive parity. What does that even mean? It's simple, really. It just means that if the algorithm gives a black defendant and a white defendant both a risk score of, say, 7 out of 10, then they both have roughly the same statistical chance of reoffending. For North Point, fairness was all about the accuracy of the prediction itself. A 7 is a 7 is a 7. That's it. But ProPublica was looking at it through a totally different lens. Their definition of fairness was equalized odds. They were arguing that a truly fair system is one where the mistakes are spread out evenly. So if the algorithm is going to be wrong sometimes, and it will be, it needs to be wrong at the same rate for everybody. The consequences of its errors shouldn't hit one racial group harder than another. And this right here is the absolute heart of the dilemma. You've got two completely logical, totally reasonable definitions of what it means to be fair. And here's the kicker. Mathematically, when you're working with messy, real-world data, you literally cannot have both at the same time. It's impossible. This leads us to something called the impossibility theorem. It all starts with a tough reality. In the real world, different groups have different base rates of arrest and reconviction, often for complex historical reasons like where police patrols are concentrated. So, because that difference exists in the data from the start, you're forced to make a choice. You can either build your algorithm so that a risk score means the same thing for everyone, or you can build it so that its error rates are the same for everyone. It's a proven mathematical fact. You can't have your cake and eat it too. Okay, so this mathematical trap forces us to dig even deeper. If the logic of the code is locked in this paradox, maybe the problem isn't the code itself. Maybe the problem is the data we're feeding it. It's like the well is poisoned long before the algorithm ever takes a drink. So you gotta ask, right? If the algorithm wasn't programmed to be biased, if it doesn't even use race as an input, how does it end up producing these racially skewed results? What is it in the data that's leading it down this path? Well, the answer comes down to this really important idea called proxy variables. You see, the COMPAS algorithm is smart. It doesn't need to ask, what is your race, to figure things out. Instead, it looks at other seemingly harmless questions whose answers end up being powerful stand-ins, or proxies, for race. And here's some real-world examples. The algorithm asks for your zip code. Well, because of a long history of housing segregation, zip codes are often strongly correlated with race. It asks if your friends or family have been victims of crime. That might sound neutral, but it's a reality that's far more common in heavily policed minority communities. So without ever using the word race, the algorithm learns to associate these proxies with risk, effectively absorbing the biases that already exist in society. And this creates a massive legal headache. There was a landmark case, State versus Loomis, where the court actually said it was okay to use these COMPAS scores during sentencing. But here's the catch. The algorithm is a corporate trade secret. It's proprietary. So the defendants' lawyers couldn't look inside. They couldn't challenge its logic. They were literally fighting a black box, a secret accuser whose reasoning they weren't allowed to see. That's a huge problem for due process. So this whole mess pushes us toward a really fundamental question. If the algorithm is flawed, can't we just fix it? Can we just write better code, tweak the math, and create a fairer outcome? Well, a lot of very smart people have tried. Researchers have tried all sorts of clever technical fixes, and you can see a few of them here. But they all slam into the same wall. You can't fix one thing without breaking something else. It's like a game of whack-a-mole. You try to rebalance the data to force fair outcomes, but then the model's overall accuracy just tanks. Or you fix one type of error, and another one gets way worse. There's no easy fix. And speaking of accuracy tanking, get a load of this number. One of the technical fixes, called the prejudice remover, actually did manage to flip the bias, but its predictions were only accurate 38% of the time. That is way, way worse than just flipping a coin. It really shows you the limits of trying to solve a deep social problem with a purely technical patch. This whole situation forces us to confront a huge ethical question that's much bigger than just code. I mean, think about it. Our entire legal system is built on the idea that you have a right to confront your accuser, to see the evidence that's being used against you. So what happens when that evidence isn't a person, but a secret piece of code owned by a private company? And that really is what it all comes down to. The COMPAS dilemma shows us loud and clear that you can't just code your way out of deeply ingrained social problems. An algorithm like this is ultimately a mirror, and right now it's just reflecting the biases that are already present in our society and in the data we feed it. So the final question we have to ask isn't just about fixing the code. It's about how we begin to fix the system the code is trying and failing to predict.